We do combinations. We spent 4 classes on permutations. We'll spend 1 on combinations, which will tell you which one is harder. Definition.
Selection of objects where the order
Doesn't matter. The example we talked about at the beginning it was hands of cards. Doesn't matter how you arrange them when you physically hold them, it's still the same combination of cards. We talked about locker combos, and what did we realize about locker combos? Yeah, what about McDonald's combos? It's when you go up and order combo number 1.
bad.
Probably bad food, but nonetheless, is that a permutation or a combination? Why? Correct. If they put the burger, the fries, then the drink, or the fries, then the burger, then the drink, does it change the combo? So we didn't mess with McDonald's. We only messed with your locker. Another example is picking a team. So if I need to pick 6 people out of this room to play volleyball, it doesn't matter who I pick first, second, third. It's the same 6 teams. Okay, so let's look at the formula first. Perms, we didn't give you the formula till halfway through. Okay, so notation is NCR, and we often read this as N choose R, and we'll read the other one as N pick R, just because it's P and C. It's equal to N factorial over N minus R factorial. What do you notice so far? It's exactly the same. There's an extra R factorial on the bottom. Okay, so that's the only difference between the 2 formulas, is this guy takes away all the order. Find it on your calc. Math left 3 is the offer. Verify it. Everyone's just trusting you. Okay, write whatever you need in the box to remember that. Before you give me the value for 8C5, turn to someone and tell them what it means. What does it mean? More specific, yes. Correct. So here are 8 different colored pens. There's one combination of 5 of them. Here's a second combination of 5 of them. Here's a third combination of 5 of them. How many times could I keep doing this? Well, you have the answer in front of you, so you tell me. 56 times I could keep doing that? So what's the difference between 8P5 and 8C5? Not quite.
8P5 is a lot higher.
It is a lot higher, okay? Why? What's the difference between them? The order matters. So here's one combination of 5 colors out of my 8. Doesn't matter however I arrange them, that's still one combination, correct? Well, here's where you get into permutations. There's one order. Here's a second order. Here's a third order. Here's a fourth order. So if I needed to put them in order, I'm going to have way more different possibilities than if I'm just choosing them. Okay, so again, another example, there is 5 out of my 8. But if I need to start arranging them, that is a different permutation. It's not a different combination, but it's a different permutation. 10C3, how many different ways can I choose 3 pens from 10 of them? 7C3, offer of 35. 7C4? Ooh, look at that. Why are they both 35? So 7C anything will be 35? Okay, so why are these two both 35?
Because 7 minus 3 is going to be 4 factorial times 3 factorial, and 7 minus...
You lost me there, say it again. 7 minus 3.
7 minus 3 equals 4.
Yes.
And that's going to be 4 factorial times 3 factorial,
You lost me. 7 minus 3 equals 4. I was with you, then you lost me where the factorials went.
So like NCR formula.
Yes.
N factorial.
Gotcha.
Which is 7 in both
Okay,
cases.
I'm just going to write because I'm visual. Oop, 7C4. So you're saying it's 7 on the top?
Over 7 minus 3, which is going to be 4 factorial, times 3 factorial. And then the other one is going to be 7 factorial over 7 factorial minus 4 factorial, which is going to be
I think you want 7 minus 4 factorial.
yeah,
Okay, which will be 3 factorial.
times 4 factorial.
Okay, so what's the relationship? Why are 3 and 4 the same?
Because on the bottom you can get the same thing.
Okay, so what's the relationship between n and r? Okay, following the same logic, let's say 8C2 has to be the same as what?
8C6.
Correct. Why? What's the relationship there? Chantal, you should see the look on your face. It's like, the two r's have to add together to be n. So it's because 3 plus 4 equals 7. So the general rule, we say NCR equals NC, and then in brackets n minus r. So for example, 8C2 is the same as 8C6. 8C1 is the same as 8C7. 8C3 is going to be the same as 8C6 is going to be the same as. What if I did 9C1 is the same as 9C8? What if I did 100C2 would be the same as? That's going to become important tomorrow when we look at binomial theorem. Okay. Moving on, 7C7. 1, why? Well, what does this mean?
You have 7 things.
7 objects, and you need to choose all of them. And how many ways can you do that? 1. So that links us to the second general rule that says NCN, no matter what n is, so 10C10, 13C13, 2C2 is always going to be 1, because you're picking all of the objects that you have. What about a 9C0? So that means you have 9 objects, and you are picking 0. Well, how many ways can you do that? 1. Which leads us to the second, or third, I should say, general rule that NC0 doesn't matter what n is always going to be 1. Those are going to become important a little bit today, but more specifically when we do binomial theorem. Okay, so let's look at the first example. We're going back to students, and Jack's going to make an appearance here. Jack, pain in the butt.
Jack's my homeboy.
Jack's your homeboy. Keywords. So in the main part of the question. Part B.
Jack asked which how many combinations?
So didn't we do committees when we did perms? Yeah, we did actually. There were a couple examples where we did committees. So what's the difference? Why is one a perm and one a com? Say that again. So does that make it an order question or not an order question? Okay, so if I'm going to pick 3 people to be on this committee, who am I going to pick? I'm going to pick Hunter because he seems like he's fun, so he can plan all the music. And I'm going to pick Kelsey to do the finances because I trust him, and I'm going to pick Jenna because she's responsible and she's a girl and she's actually going to get stuff done. So does it matter who I pick first? If I pick Jenna first, then I pick Hunter, then I pick Kelsey. Is that changing our dance committee? No, so the order doesn't matter. Well, when does the order matter? Well, let's say I have 3 positions. I have the chairperson, I have the finance person, and I have the events person. If I pick Hunter as chairperson, Kelsey as finance person, and Jenna as the events person, that's one committee. But let's say switch it up, and now I'm going to pick Kelsey as the chairperson, Hunter as the finance person, scares me a little bit, and Jenna as the events person. Does that make the exact same dance committee? Do they all do the exact same thing? No. So the difference with committees, if you're just picking general members of the committee, that's a combination. If you're picking positions, that's a permutation. I'm going to write that, or say that again in case you want to write that down. If you're picking general committee members, it's going to be a combination. General committee members, combination. Specific positions, permutation. That was supposed to go in the box, by the way. I just realized some of you wrote it off to the side. It's supposed to go in. Just put an arrow into the box. Didn't notice the box, did you? I'll try to bold it next time.
I noticed the box, I just thought that was something else.
So first thing you need to know about combination is there are no blanks. That's permutations, that's fundamental counting principle, and your brain's going to want to start drawing blanks. It's going to think 5, 3, 3 is a lower number, 3 blanks. And then you're going to want to try to fill in the blanks, but that's ordering, because you're doing one blank after the next one. No blanks, this is all done with the formula. How many people do we have to choose from, and how many do we need to choose? We have 5 to choose from, and we need to choose. That's it. That's 5 people choosing any 3 for a dance committee, a team, a group of anything. Let's do it without the calc, just in case this appears in the non-calc section. So let's use the formula. N factorial on the top gives us 5 factorial. N minus r on the bottom gives us 5 minus 3 factorial. And then we have an extra r factorial because it's a combination. You've memorized 5 factorial is? On the bottom, 5 minus 3 is 2 factorial, and you've memorized 2 factorial is? And a 3 factorial is? And we're going to do the bottom first, 2 times 6. And 120 divided by 12, 10. Okay, so if it does appear in the non-calculator section, it's a straight-up formula question. Jack has to be chairperson. How many committees are possible? So we need to have Jack, and we need to have 2 other people. That's what the question's really telling you. You have to have Jack on your committee. We don't care who else is with him. So what we're going to do is pick them separately. There is 1 Jack, and we need him. That gives us a 1C1. How many remaining people are there to choose from? How many remaining people are there to choose from? How many remaining people are there to choose from? 4. There are 4 people left, and how many of them do we need to pick? 2. Am I multiplying these or adding them, and why? What were the keywords before we looked at multiplying versus adding? And, or. Do I need Jack and 2 other people, or do I need Jack or 2 other people? And, so it tells you we are multiplying. Do not put a 1C1 into your calculator. What do you know about NCN? Look in the box above. If you can't remember, an NCN is always going to be 1. So don't waste your time putting that into your calculator. There's one way to pick Jack. Go ahead and figure out 4C4 without your calc. 4C2, sorry, without your calc. So there'll be a 4 factorial on the top, a 2 factorial, and a 2 factorial on the bottom. 4 factorial is 24. 2 factorial on the bottom is times 2 is, so 24 divided by 4, 6. There's a combination with restriction question. Questions so far? Read to read number 3. Keywords. Apparently there are no keywords. Committees of 5.
8 possible choices.
8 possible choices.
Jack and Jill refuse to work together.
Jack and Jill refuse. So this is the equivalent of our not together that we did in permutations, and it's done very differently. So the first thing you got to figure out is this a com or is it a perm, because it changed how you do the question. Why is this a combination?
Because it doesn't matter who the committee is.
Correct. We're not electing a chairperson and a vice president and whatever else. This is a straight up com question. For not togethers, there's always going to be 3 cases. We could have Jack on the committee, which means we don't have Jill on the committee, and then we still need 4 other people. Second possibility, Jill is on the committee, Jack is not, and then we need 4 other people. What's the third possibility? To heck with both of you. No to Jack, no to Jill, and then we still need to pick our 5 people. Okay? That's the way not together is always going to work. You can have one or the other or neither. Okay, so if we pick Jack, that's a 1C1. We can't have Jill, so we started with 8. Jack is gone, Jill is gone. How many are left? 6. Oh, I hate that we're in the middle of the example, but we'll have to pause. See you in a bit.